Gordodon was a small, sailed-backed herbivore from the time before the dinosaurs. It lived 299 million years ago, at the boundary of the late Carboniferous and early Permian periods. This was not long after tetrapods, four-legged animals, had first evolved to become herbivores. Gordodon was more specialized than the other contemporary plant eaters, and even had adaptations for herbivory that wouldn't be seen again until after the Permian period. Gordodon was first found in New Mexico in 2013 and named in 2018. Gordodon means fat tooth, which, while somewhat odd, is in reference to its distinctive large front teeth. The name also refers to Alamogordo, a city close to where the Gordodon holotype was found. The species name, Craneri, is in honor of the paleontologist Carl Craner for his work on New Mexican Permian geology. The only known Gordodon specimen consists of just the front upper half of the skeleton. Most of what is preserved is in very good condition, but an accident during its excavation created cuts along the slab, including on the skull. The fossil was found in the New Mexican Bursum Formation. When Gordodon was alive, this part of North America was a coastal plain. It was so close to the sea that the environment preserved in the Bursum Formation alternates between terrestrial and marine. Gordodon was the first new species of its clade, Edaphosauridae, found in over 30 years. Although the title of newest Edaphosaurid was usurped in the following year by Remigiomontanus. The most famous Edaphosaurid is the namesake of the clade, the fellow plant eater Edaphosaurus. It consisted of several species, and is best known for its appearance in BBC's Walking with Monsters. Like the more famous Permian predator Dimetrodon, Edaphosaurids like Gordodon were synapsids, meaning they were more closely related to mammals than to reptiles. Despite their close relationship, the sails of the Edaphosaurids and Dimetrodon were actually the result of convergent evolution. Indeed, the contemporary amphibian Platyhystrix also independently evolved a similar sail on its back. While such sails were once thought to have evolved to aid in thermoregulation, they are now considered more likely to have been the result of sexual selection. However, their true function is still under debate, and may not have been consistent across the different clades. The shape of Gordodon's sail is distinct, since the front half comes down more gradually than those of other Edaphosaurids, whose sails have a more semicircular shape. The sails of many Edaphosaurids had protrusions along the bones. Those of Gordodon are small and have a curved, thorn-like shape. The distribution of these protrusions is much more random than that of its relatives. The Gordodon holotype is estimated to have weighed only 34 kilograms and to have had a length of 1.5 meters. Given the fusion of its vertebrae, it is not thought to have been a juvenile. Although it was small compared to some later species of Edaphosaurus, Gordodon's size was comparable to that of other contemporary Edaphosaurids and other early herbivores. Gordodon's skull is much more unique than its body size, both for an Edaphosaurid and an early herbivore. Its round head was small in absolute terms, but proportionately large for an Edaphosaurid. The bone above its eyes was elevated, creating a distinctive ridge. Gordodon's snout was also longer and narrower than that of Edaphosaurus. Likewise, it had a longer neck than the other Edaphosaurids. The strangest part of Gordodon's skull was its teeth. The front teeth were chisel-shaped, with a pointed tip, and were substantially larger than those of other Edaphosaurids. They are thought to have been used for cropping its food, making them analogous to the incisors of mammals. While the teeth of its relatives were fairly continuous, there was a large space called a diastema between Gordodon's large incisors and the rest of the teeth. Diastemas are present in many modern mammalian herbivores such as rodents, but Gordodon's diastema is the oldest one known to science. They didn't evolve again until the emergence of tritylodontid cynodonts during the end of the Triassic period, 95 million years after Gordodon. Its cheek teeth were small and peg-like. However, Gordodon was more than a stem mammal with rodent-like teeth. Much like its relative Edaphosaurus here, smaller versions of the cheek teeth were arranged in dental batteries inside its mouth. It was these bizarre dental plates which did most of the work to grind Gordodon's food. Gordodon is considered to have been a selective feeder, focusing on eating high-quality food. Its narrow snout is similar to modern selective browsers, and would have helped it pick out the best parts from plants. The same is true of its incisors and diastema. Further evidence for a selective diet comes from its ribs, which are not curved like those of Edaphosaurus. Because of this, Gordodon isn't thought to have had its barrel-shaped chest, which held the large gut needed to slowly digest low-quality plant matter. A diet of nutrient-rich, low-fiber plants is often seen as a necessary step for the evolution of the more generalized herbivory seen in Edaphosaurus. However, Gordodon's strong specializations for selective feeding relative to Edaphosaurus and their omnivorous ancestors indicate it wasn't just a stepping stone in the evolution of less picky herbivores. Instead, it doubled down on its selective diet, allowing it to coexist with the generalist plant eaters. As for what it was eating, seeds were some of the most nutritious vegetation which existed when Gordodon was alive. With its dental batteries and robust lower jaw, it would have had a bite powerful enough to crush even the hardest seeds. True fruit wouldn't evolve until the emergence of angiosperms well into the Mesozoic era. However, some gymnosperms like cycads do have large seeds analogous to the fruits of angiosperms. Therefore, Gordodon may have been a specialized frugivore, or fruit eater, before proper fruit evolved. While not as large as Edaphosaurus or as terrifying as Dimetrodon, Gordodon displayed key evolutionary first, such as its diastema, and has expanded the known ecological diversity of Edaphosauridae. Gordodon has also greatly enriched our understanding of the development of terrestrial herbivory, showing just how quickly some animals can become specialized. Thank you for watching. I hope you learned something interesting. If you enjoyed this video, please remember to hit the like button, and subscribe if you'd like to see more. Finally, be sure to have a great day.